Okay. So, let's go ahead and get started. First, roll. Just give me your last names. Madison. And your last name? All right. So we have been talking about quite a few different ways of analyzing data. And we've said that we can measure it with things like mean, median, mode, and range. We can find different locations in the data with uh, standard deviation. We can see how closely related data is with our coefficients. There's a lot of different ways that we can measure data. Now, when we actually look at data, it also helps to model the data. Okay? So what I mean by modeling the data is understanding how the data works overall, and maybe even be able to predict what the data would look like given a certain situation. So for this, we have something called linear equations. And these are kind of the most basic way of modeling data. However, where our measurements of data kind of work for everything, sometimes certain situations are going to be modeled in very specific ways. Okay? Now, linear equations, again, they're very basic, but they fit a lot of these different situations. So the very basic way that we can look at them is to say that the general form of a linear equation is y equals mx plus b. Okay? And well, my program's just crashed. Let me restart that for us. Okay. So again, this is the general form of a linear equation. And like I said, these things fit a lot of different situations. So, what do each of these pieces and parts mean? Okay, first of all, y and x. These are both variables. We've seen these variables before. In fact, just last time when we were talking about the correlation coefficient, we were comparing y and x and seeing if they were correlated. So these could be any two variables that we have in our data. Okay. Typically, we think about it as x is something that we're going to be changing, and when we change x, it's going to affect y. So what we're doing here is we're seeing what happens to y. We plug in an x and then we get out a y. M is what's called the slope. Should label these two. Okay? So slope is how is this thing changing? You know, how quickly is it changing? Is it going to be increasing? Is it going to be decreasing? How quickly is it going to be increasing or decreasing? That's what slope tells us. B is kind of like a modifier. It's basically going to tell us where this thing starts, usually, not always. I'll explain that a little bit more in a minute. But this is what we call our y-intercept. Okay? And again, this is a basic form of a linear equation. And you've probably seen this before. You probably saw it in somewhere like high school. Now, in stats, we have a slightly different version of it. And it's actually up on the board. I'll point it out. It's right here. So it's the exact same equation, it does the exact same things, you just have different names for two of our numbers. So I'll write it here. Y equals b sub 1 times x plus b sub 0, or b sub o. But all of these represent the same thing. Y is still one of those variables. B sub 1 is what's replacing m, so it's still our slope. X, another variable. And again, it's what we're typically going to be plugging things in for. And b sub o is our y-intercept. It's that thing that's basically modifying how this thing starts and changes where the other variables go up or down. But again, this is probably the version that you've seen before, somewhere in high school algebra. This is the version that we'll be using in statistics. So, let's take a closer look at each of these pieces and parts on a graph, because that's what this is really meant for, is graphs. I'll just make a quick graph for us real quick. Okay? So when we have a graph like this is called a Cartesian grid. So the horizontal line here is called the x-axis. Basically, it's a number line that shows where x is. Again, we plug in an x into this equation. This is basically going to show us where that x lands. It's a number line. We have positive values in this direction, and we have negative values in this direction, meaning that right here in the middle, we have 0. Oops, that should be negative. So this might be something like, 1, 2, 3, 4, and then 5 at the end. And then on the opposite side, we would have -1, -2, -3, -4, and -5 at the end. Again, it's a number line. This other line here is called the y-axis. It does the exact same thing that the x-axis does, but for y. It's a number line. 0 in the middle, positive values towards the top, negative values towards the bottom. So this one would look like 1, 2, 3, 4 positives, -1, -2, -3, and -4 negatives. So it's two number lines that are intersecting at a 90-degree angle. Any questions? Okay. So, when we are dealing with these graphs, we are typically going to be looking at points. So, for instance, if I have a point here, the way we would read this point is to first look at the x-axis. Where does this land on our x-axis? Well, if we read across here, it lines up with 3 on our x-axis. That's the first part of this coordinate. Then we look at where it lands on the y-axis. So if we read, seems like it's lining up with 2. And there's the location. Again, what we call this is a coordinate. So the coordinate for this, or how we would read this, is 3, 2. What this is saying is that our x that we plugged into whatever linear equation we have is 3, and the y that it gave out for us was 2. Now, we don't know in just with one point what the b sub 1 and b sub o is. We can't tell from just one point. We would need more points than that. But when you plug in a number for x, it's going to give you out a number for y. So when we plugged in 3 for whatever linear equation this was, it gave us out a 2. That's the basic idea of how these work. Any questions? None? Okay. So let's try a linear equation real quick. Okay. Let's say there's a phone company, and the way that they do their billing is with a linear equation. Okay. So what they do is there's a flat rate fee. So if you subscribe to this phone company's service, no matter what, no matter how much you use their phone service, each month you're going to pay, let's say, $25. Okay? Then, for every minute that you use their service, they're going to charge you 20 cents. Okay? So again, what they're saying here is, beginning of the month, no matter what, if you don't use this phone at all, you're still going to pay $25. But for every minute that you use the phone, it's going to add an additional 20 cents. Okay? So, let's translate this into one of our linear equations. So again, the basic form of the linear equation is y equals b sub 1 x plus b sub o. Okay? So, here's how this works. Again, these linear equations have a point that they kind of start. Well, where do you think this thing's going to start, thinking about the way this bill works? Like I said, it doesn't matter how much you use the phone, you're going to have an initial fee, right? And your fee, the bill, is going to start where? Excuse me? Yes. So at the beginning of the month, if you don't use any phone time at all, what's your bill going to be? 25. So that's where this thing is always going to start. This right here is our b sub o, our y-intercept. Again, this is where this linear equation kind of starts. So we can put that in. B sub o equals 25. Okay. And then we have a price per minute. So, depending on how many minutes we use, we're going to be multiplying those minutes by 0.2. Okay? So do we see anywhere in this equation that we're going to be multiplying? Where? B sub 1, yeah. So b sub 1 is going to be the multiplier here. B sub 1 is our 0.2. So let's go ahead and plug those in. We now have y equals 0.20x plus 25. Okay, so what does that mean our y and x represent? Well, y is the thing this whole thing is equal to. So if we multiply our minutes times 0.2 and then add 25, we get y. So y is our total bill. Okay? X is the thing that we're multiplying by 0.2, so what does that mean x is? It's the number of what? Minutes, yeah. So y is the total bill. X is the number of minutes. With me so far? Any questions? All right. So let's try some things. First of all, let's just plug in a number for x, a certain amount of minutes. Let's say in a month we were pretty conservative, we used 150 minutes. Okay, so we're going to plug in 150 for x here. So that would mean we have y equals 0.20 times 150. And notice that when I plug in, this number for x, I'm using parentheses. That's very important. Plus 25. Basically, what those parentheses do for me is make sure that I'm using the correct operation. What I mean by operation is add, subtract, multiply, or divide. So you can imagine that if for some reason my x was negative and I plugged it into this equation, if I didn't have those parentheses there, this would look like 0.2 minus 150 instead of what we know we should be doing, which is multiplying it. So in this case, the parentheses are making sure that we multiply these numbers. So that's something you should make sure you always do. If you plug in a number for a variable, use parentheses around it. All right, let's see what we get. So like I've said before, when we're dealing with any kind of numbers in operations, we need to follow our order of operations. So that goes parentheses first, then exponents, then multiply, then divide, and add, and then subtract. So, I don't see anything that we can do inside of our parentheses. That's just a normal value. I don't see any exponents here. I do see multiply though. We've got 0.2 times 150. So let's go ahead and figure what that is. So 0.2 times 150 is 30. So now we have y equals 30 plus 25. Okay, no division, but I do see addition. So 30 plus 25 is 55. So if we use 150 minutes, we have to pay a bill of $55 that month. Does that make sense? What questions do we have? None?
So in this problem, will they give us, like, so if we have one similar to this, will they give us how many minutes you've used? Like,
It depends on the problem. They might give you, okay, how many minutes you used, so plug that in, and they might be asking in that case, what is the bill that month? Or, the one I was just about to show you, maybe they don't. Maybe they give you something else. Something like, okay, the bill is, I don't know, $300. Big bill. How many minutes were used? Okay, so they might give you one variable, they might give you the other variable. There's all sorts of different things that they might give you and things that they might not give you. And in that case, you need to solve. So this one, just as it is set up so that we can easily figure out what y is. However, if we get any other number, we then have to start kind of playing around with this linear equation and figuring out what we need to do to solve it. And what I mean by solve is get the variable that we're looking for by itself. So if our bill is $300, then what does that mean we're plugging $300 into? Which one of these things? Y, yeah. So we're going to plug in 300 for y. And then, of course, 0.2 is going to be the same no matter where we are. We don't have an x. We don't know how many minutes. That's what we're trying to figure out. And we have plus 25. Okay, so we know that the bill is $300, but we don't know how many minutes. We want to know how many minutes were used to get this bill. So we need to solve for x. We need to get x by itself. Just like up here where y was by itself, and it was very easy to figure out what y was. Okay, So how do we do this? Well, what we're going to do is we're going to move everything that isn't an x over to the other side. We want to do things that will basically eliminate the numbers on this side so we don't have them around x. So for instance, I could either divide this side by 0.2 to get it off of x, since it's multiplying by x right now. Dividing by 0.2 would be the opposite of that, and they would cancel. Similarly, plus 25. I could subtract 25 from this whole side. And because subtraction is the opposite from addition, it would cancel this 25. Now I am going to subtract the 25, and there's a reason for that. If I divide the 0.2 off of this side, it has to divide off of the entire side. So I'd also have to divide 25 by 0.2, and I don't want to do that. It'd be much easier if I just subtract 25 from this side, and that means those cancel. However, equations like this show balance. So we have to balance this thing out. If I do negative 25 to this side, I have to do negative 25 to this side. Does that make sense? Yeah? Okay. So 300 minus 25 is going to give us 275. So now our equation looks like this. 275 equals 0.2x. Again, we want to get x by itself. We want to cancel everything that is not an x. Well, like I said, we could divide by 0.2. And now that we don't have an extra number over here that we'd have to divide by, that's going to be pretty easy. We just divide this whole side by 0.2. Again, the reason this works is because 0.2 is multiplying by x right now. So if we divide, that's the opposite of multiplying, and it cancels. But we have to do the same thing to the other side. So divide this side by 0.2. Okay? And if we divide that, we get 1,375. Oops, 1,375. And there's nothing left on this side except for x. So there's how many minutes we used. Does that make sense? Okay. And we can do that for any of these things. Maybe for some reason we didn't know the minute or the price per minute. If we knew the y and the x, then we could solve for that. Basically doing the exact same thing we just did. Okay, any questions? All right. Now, here's the other way that these linear equation things are very useful. Like I said, their real life is in a graph. So let me make another graph here real quick. Oh, that's all right. And I'll rough this out a little bit. Let's see, 1, 2. Oh no, that's not going to work at all. Let me start over. Okay, and I'm going to count by fives on these things. So this will be 5, 10, 15, 20, 25, 30, 35, 40. And I'll just fill in the rest of these for us. That doesn't matter. Okay. So again, the formula, the equation that we found was y equals 0.2 x plus 25. So here's how these things work when we graph them. First of all, we really ought to translate this into a fraction, and there's a good reason for that. So 0.2 as a fraction is 1/5. And the reason we want to translate that into a fraction is because the parts of this fraction tell us how many steps to take on our graph. Okay. Now the first thing we want to do is find a point on our graph that we can actually put on here. And well, we know one already. Like I said, this bill is going to start where, no matter what. If we don't use any minutes on our plan, where does this bill start? At where?
Here.
Nope. 25, yeah. So if we use 0 minutes, which x is our minutes, if we use 0 minutes, our bill is 25. So we have a point right here. Make it nice and big. Okay. This slope right here, like I said, tells us how much we're going to increase or decrease. So what this says is each step we're going to increase by 1 on the y and 5 on the x. So the top part tells us how much we're increasing on the y, the bottom part tells us how much we're increasing on the x. So each step is going to be 1 on the y, 5 on the x. And remember, this is counted in fives. So if I go up 1, it's not really a whole lot. Up 1 over 5 is 5. Up 1 over 5 is 10. Up 1 over 5 is 15. Up 1 over 5, let's see, 1, 2, 3, 4, and yeah, that'd be 30. And it would continue like this. Okay? Now, this part back here doesn't make a whole lot of sense for us, but it is theoretically there with our equation. We can't have a negative bill. It doesn't make any kind of sense. So we can just ignore this. But it is theoretically part of our equation. It's just in the real world it wouldn't matter. The rest of this, though, is very helpful because what it does for us is we can say, all right, what if our minutes used is something like 40? Well, go from 40 up to here, see where it meets, and that's somewhere around 30, like 33 or something like that. Like, let's see, 40 times 0.2 plus 25. Actually, it's exactly that, 33. Yeah. Okay. So this graph here allows us to predict what our overall equation does. We don't need to put in points. We don't need to solve things, technically. If we can make this graph, we can just look at it and say, okay, I know exactly what will happen no matter what. I can look anywhere on my minutes or anywhere on my price, and I can figure out what the other one is. I don't need to solve. Does that make sense? Any questions? None? Okay. So again, linear equations. Sometimes we need specific models for whatever we're analyzing for our data. And these linear equations fit most of those models. So the one you're probably used to seeing is y equals mx plus b, where m is the slope and b is the y-intercept. But in statistics, we use a slightly different version, y equals b sub 1 x plus b sub o, where b sub 1 is the slope and b sub o is the y-intercept. Okay. So I believe that will do it for today. Next week, we will have a test, not a quiz, a test. And I believe I will deliver that test on Friday of next week. To prepare for that, I'm going to be giving us a study sheet, a review, if you will. And I'll be emailing that out later today. That review will be for a grade. I expect it on Friday. Okay? Other than that, I'll see y'all on Monday. Have a good weekend. Yes?